Chapter 6.2 is going to be using the sum and difference formulas. So here are the sum and difference formulas for cosine, sine, and tangent. Sum and difference here referring to obviously addition and subtraction, and you can see that the angles in here are being added and subtracted. So before, when we were determining the exact value of a trig function evaluated at an angle, we were able to find the reference angle, and the reference angle was always a nice angle like 30, 45, or 60 that is on the table. Now we're going to be finding ones that are not those nice angles, so we won't be able to use that method. So for example here, if we have cosine of a plus b, cosine of an angle plus another angle, we can chop it up and rewrite it as cosine of a times cosine of b minus sine of a times sine of b. And then you can read through all of these other ones. So we're going to be using these formulas. So let's go ahead and do this first one. So let's find the exact value of cosine of 45 degrees minus 30 degrees. So first, it's good to note that this is just equal to cosine of 15 degrees, right? 45 minus 30. So if this just said find cosine of 15 degrees without using your calculator, that's not one of our main reference angles that we know. Technically, it is a reference angle because it's between 0 and 90, but it's not one that we have memorized, or that's not on the table, so we have to use one of these formulas here. So we're going to be using the one for cosine, and we're going to be using the one for cosine a minus b, because it's 45 minus 30. So writing down this formula, so it's cosine a cosine b minus sine a times sine b, and we just have to identify what a and b are. So cosine of the 45 degrees, 45 is a and 30 is b. So we're just going to plug those in and say that's cosine of 45 degrees times cosine of 30 degrees minus sine of 45 times sine of 30. Okay, so all we have to do is evaluate each one of those individually and then simplify it. Cosine of 45 degrees, so this is on the table. Cosine of 45 degrees is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2. Sine of 45 degrees is radical 2 over 2. And sine of 30 degrees is 1/2. Okay, so simplifying this a little bit, we multiply numerators. Radical 2 times radical 3 is radical 6. So that's radical 6 over 2 times 2 is 4. Radical 6 over, oops, I actually put minus here. This should be a plus between all these. Plus, plus, plus. So that's just from the formula up there. I just wrote it down incorrectly. For the next one, we have plus radical 2 times 1, so radical 2, over 2 times 2 is 4. And now we can just put these into one fraction here. This would be radical 6 plus radical 2, all over 4. And we can leave it just like that, can't simplify that. Okay, so cosine of 15 degrees is radical 6 plus radical 2 divided by 4. Okay, so let's do another one here. Find the exact value of sine of 19 pi over 12 using the fact that 19 pi over 12 can be split up as 4 pi over 3 plus pi over 4. Okay, so we could try doing this a reference angle way and it might work, but we are going to use it obviously this formula way, so we're using sine of 19 pi over 12. And we're using the fact that that's equal to sine of 4 pi over 3 plus pi over 4. So the formula we're going to be using here is going to be the one with sine with addition. So that's going to be the sum formula for sine, which is right here. So I'm just going to write that down. And let's figure this out now. So it's going to be sine of 4 pi over 3 plus pi over 4. So 4 pi over 3 is A, pi over 4 is B. It actually doesn't even matter which one you choose to be which because it is addition in this case. So it's going to be sine of 4 pi over 3 times cosine of pi over 4 plus cosine of 4 pi over 3 times sine of pi over 4. So now we just have to evaluate each one of them separately. Sine of 4 pi over 3 and cosine of 4 pi over 3, we can do that using the reference angle way. So using the reference angle method here, sine of 4 pi over 3 is going to end up being negative radical 3 over 2. So I'm just going to skip to the answer because we should already know how to do that. And cosine of pi over 4, that's on the table, that's radical 2 over 2. Cosine of 4 pi over 3 using a reference angle is negative 1/2. And sine of pi over 4 on the table, that's radical 2 over 2. Okay, so simplifying this, we're going to end up getting, I'll just skip to the answer for simplifying this now. It's going to be negative radical 6 minus radical 2 over 4, which we could factor out a negative in the numerator and put it out front and make it radical 6 plus radical 2 in the numerator all over 4. Okay, so that is the answer for this one. Let's do one more of these. So find the value of tangent of 5 pi over 12 using the fact that 5 pi over 12 equals pi over 4 plus pi over 6. Okay, so that means that tangent of 5 pi over 12 is going to equal tangent of pi over 4 plus pi over 6. Okay, so that means we're going to be using the sum formula for tangent. So we go up to the formulas and we see that tangent is going to be right here. So let's write that down. So tangent of A plus B is equal to tangent of A plus tangent of B divided by 1 minus tan A times tan B. Okay, so we are trying to evaluate tangent of pi over 4 plus pi over 6. So let's let A be pi over 4 and B is the pi over 6. So it's going to be tangent of pi over 4 plus tangent of pi over 6 divided by 1 minus tangent of pi over 4 times tangent of pi over 6. So these are all reference angles that are on our table, or hopefully we start to memorize these. So we can just plug this on in, plug everything in. Tangent of pi over 4 is 1. Tangent of pi over 6 is radical 3 over 3. And that's going to be over 1 minus 1 times radical 3 over 3. Okay, so just plugging in for everything. And now we just have to simplify this. So that's going to be equal to, in the numerator, I'm just going to leave that alone for right now, 1 plus radical 3 over 3 divided by 1 minus radical 3 over 3. So what we have to do here to simplify this is a complex fraction. We have to multiply the numerator and denominator by 3 because that will cancel off the smaller denominators in the numerator and denominator. So when we do that, we're going to end up getting 1 times 3 is 3. Radical 3 over 3 times 3, the 3's cancel, so that's radical 3 for just that term. So the whole numerator becomes 3 plus radical 3. Same thing in the denominator, 1 times 3 is 3, minus radical 3 over 3 times 3, the 3's cancel, so we get 3 minus radical 3 in the denominator, and that's the simplified version of this. Okay, so that is tangent of 5 pi over 12. Once again, you could plug this in the calculator in radian mode, tangent of 5 pi over 12. You'll get a decimal. You could plug in your answer in the calculator and make sure you get the same decimal answer. Okay, so let's do 2 more main questions here. A little bit more complicated for these. We're going to have to draw some triangles here. So suppose that sine of A is 12 over 13 in quadrant 2, and sine of B is 3 over 5 in quadrant 1. We want to find the exact values of the following: cosine of A, cosine of B, cosine A plus B, and sine of A plus B. So let's find this without finding the actual angles. Let's do this by drawing triangles. So let's do it for angle A. So we're told angle A is in quadrant 2, so we just plop it somewhere in quadrant 2 and label it A. So we can create a right triangle here. And we can use this little reference angle in there to help us. So sine is opposite over hypotenuse, so this is going to be 12 and 13. The missing side here, we can do a squared plus b squared equals c squared if we're not sure. That would give us 5. But we have to be careful because we're going in the negative x direction. So negative x direction because it's to the left of the origin. So we have to make sure that we know that it's negative 5. Okay, so that's going to be for A. Let's do the same thing for B. So we have this in quadrant 1 because we were told B is in quadrant 1. And there's the angle for B. So let's create a right triangle once again. And we were told that cosine is, or no, not cosine, sine. We were told that sine of B is 3 over 5. So that's going to be opposite over hypotenuse. And once again, we have to solve for the missing side. So hopefully we know this one by now. This one ends up being a side of 4. We know it's positive 4 because it is in the positive x direction. Okay, so we have these. So now we can just go ahead and do these questions. So the first two, we have cosine of A. So here is angle A. So we just need to find cosine of A. So that's going to be adjacent over hypotenuse. So that is nice and easy. Adjacent over hypotenuse over here is negative 5 over 13. Okay, so we really didn't have to do any work for that one. So now for cosine of B, here is B over here, angle B. Cosine of B, adjacent over hypotenuse, is going to be 4 over 5. Once again, pretty easy. We didn't have to do anything. But now for these ones down here, we have to do a little bit more work. We have cosine of A plus B. So cosine of A plus B, the formula, I'm going to write the formula down. It's cosine A cosine B minus sine A times sine B. So cosine of A we actually already found. Cosine of A was negative 5 over 13. So negative 5 over 13 times cosine of B. Cosine of B we already found also. That was 4 over 5. Minus sine A and sine B were both given to us. Sine A was 12 over 13. And sine B was 3 over 5. Okay, so all we need to do is evaluate this and simplify it. So that's going to be negative 20 over 65 minus 36 over 65, which is going to give us negative 56 over 65. Okay, and now for sine A plus B, we're going to have the formula, so let's write this formula down. We know that's equal to sine A times cosine B plus cosine A sine B, and we just have to figure these out individually and plug them in. So sine of A is actually given to us, so that sine of B on that in part, sine of B 5. Okay, so evaluating this, multiplying the first two together, multiplying the second two together, and then adding them up, we should get 33 over 65. Okay, so the last question here, which quadrant does A plus B lie in? So this one is easier than it looks. Let's go back up to the angles to get like an estimate here. So let's say we added up angle A and then we added another rotation of B to it. Angle A is in quadrant 2 over here. Angle B is in quadrant 1. So if you're trying to think of adding quadrant 2 to quadrant 1, you might think it's going to be in quadrant 3, but that's not always the case, because if angle B is very small, then this could stay in quadrant 2, which is actually what happens here. So what we're going to do to actually do it the correct way is cosine of A plus B is negative, sine of A plus B is positive. So that only happens for both of those cases when we are in quadrant 2. So A plus B lies in quadrant 2, just like angle A was in quadrant 2. Okay, so let's do one more here. So suppose that cosine A is 1/2 in quadrant 4, sine B is negative 1/3 in quadrant 3, and we want to find the value of these three following trig functions. So let's create these triangles in the proper quadrants. So let's do angle A. So angle A is in quadrant 4, so here is our angle A, and creating a right triangle here. It's going to be using this reference angle right here. Cosine is 1/2. Cosine is adjacent over hypotenuse, and we have to find that missing side using the Pythagorean theorem, because this is not a Pythagorean triple. And we get the missing side B is radical 3. This is in the negative y direction, so we have to make sure this is negative radical 3. Okay, so let's do the same thing for angle B using sine of B is negative 1/3 in quadrant 3. So there we are in quadrant 3, so creating a right triangle here. Here's our reference angle. We're given that sine is negative 1/3, so 1/3 opposite over hypotenuse. We know that that side is going to get the negative because that is in the negative y direction. So once again, we have to use the Pythagorean theorem to find the missing side. And we end up getting that the missing side is radical 8. Radical 8 simplifies to 2 radical 2. So this side is going to be 2 radical 2, but it's in the negative x direction, so we have to know that that is going to be negative 2 radical 2. Okay, so let's do these problems now. So the first one, we have sine of A minus B. So this is going to be the sine of A minus B formula, obviously, so let's write that down. So we have sine A times cosine B minus cosine A times sine B. And we just have to fill these in. So sine A is going to be triangle A over here on the right. Sine A opposite over hypotenuse, that's negative radical 3/2 times cosine B. Cosine B is using that triangle on the bottom. That's adjacent over hypotenuse, negative 2 radical 2/3. And that's going to be minus cosine A, which is given to us, 1/2, times sine B, which is given to us, negative 1/3. Okay, so evaluating this now, both of these are going to become positive because we have negative times a negative for both that first term and the second term. So this is going to end up becoming positive 2 radical 6/6 minus, actually plus, because the negative times the negative, plus 1/6. So this is going to give us, I'm just going to rewrite this in one fraction now and write it right here to save some space. It's going to be 2 radical 6 plus 1 all over 6. So pretty messy, but that would be our answer for this first one. Looking at the second one, cosine A minus B, so writing down the formula for this one. So it equals cosine A cosine B plus sine A times sine B. So the sum formula is actually the same as the difference formula, but it would just be plugging in a negative B into B, and then simplifying using the fact if the sine or cosine or tangent is an even or odd function. So you'd have to go back to those sections to see what that means. Okay, so for cosine A is given to us, that's equal to 1/2 times cosine B. Cosine B is negative 2 radical 2 over 3 plus sine A. Sine A is negative radical 3 over 2. And sine B given to us is negative 1/3. Okay, so simplifying this, multiplying that first term, we get negative 2 radical 2 over 6. And then we get plus, because we had negative times a negative, plus radical 3 over 6. And simplifying this, that makes it radical 3, I'm just going to rearrange it, radical 3 minus 2 radical 2 over 6, and leave it just like that. Can't be simplified, so that would be our answer for that one. Okay, lastly, tangent of A minus B. So writing down this formula, and then I'm actually going to do it a different way. So here's the formula for tan A minus B from that first page. The way we can totally do it this way, find tangent of A and tangent of B using the triangles that we drew. What I'm going to do is say, or we could do tangent of A minus B. That's going to equal sine of A minus B divided by cosine of A minus B. Right? So that's just going to be that quotient identity, that tangent is equal to sine over cosine. So we already found both of these. We found sine in the first one, and we found cosine in the second one. So I'm actually going to do it using that second method. So they would both get you the same exact answer, but I'm just going to do it this way. It's a little bit easier. So sine was 2 radical 6 plus 1 divided by 6. And cosine was radical 3 minus 2 radical 2 over 6. So this would be keep, change, flip. So keep the numerator the same, change to multiplication, reciprocate the second one. So the denominators of 6 would both end up canceling, and what we're going to end up with is 2 radical 6 plus 1 divided by radical 3 minus 2 radical 2. So pretty messy for that one, but with that shortcut, it's a lot easier. If you did it the other way using the actual formula, it's pretty messy, but you should end up getting the same answer. It may not look exactly the same. You may have the negative version in the numerator, negative in the denominator, but it should end up being equivalent. Okay, so that is it for 6.2.